Okay, so let's do a practice ideal gas law problem. For the ideal gas law, you have to use your reference table to figure out which gas constant to use. If you look at the front of your reference tables, the first chart has the gas constants on the second line. You have 0.0821 liter atmospheres divided by mole Kelvin. You have 62.4 liter mmHg divided by mole Kelvin. And you have 8.314 liter kPa divided by mole Kelvin. Now, the only variable that changed in the gas constant is that pressure variable. So you determine which gas constant you're using by looking at your pressure. Let's work this problem. First things first, read the problem, figure out what they gave you, figure out what you're solving for. Number 7, what volume will 21.6 moles of neon gas occupy under a pressure of 150 kPa and a temperature of 275 Kelvin? I'm going to list everything that they want or have given me. Volume is what they want. 21.6 moles, that is the amount of gas. Remember we said moles are like dozen. And that is N. That is the variable N in the gas law equations. So N is 21.6 moles. My pressure is 150 kPa. And my temperature is 275 Kelvin. Now, do I need to do anything with the temperature in terms of converting? No, because it's already in Kelvin. There's only one gas equation that you can use to solve for a missing variable when you have the other three, and that is the ideal gas law. On your reference tables, on the back side of the front page, in the formulas column, you have the ideal gas law, and it's listed as PV equals nRT. This is also the example that we used when we had this chart, our gas law chart, our gas variable chart. We were filling out what the equation wanted, and we were figuring out what we had. This equation wanted volume. They gave us pressure and temperature and number of moles. And remember I told you that if you're not changing any of the variables, so you don't have anything on the bottom row, that means that you use the ideal gas law. PV equals nRT. So if you are changing the variables, then you cross off the variables you weren't using, and that's the equation that you're going to use. If you're only given one of each of these and you're asked to look for the other one, then you're using the ideal gas law. So I wrote my equation, and now I'm going to plug in what I'm given. My pressure is 150. I'm looking for volume. My number of moles is 21.6. R. R is on your reference tables on the front page. I have to figure out what units my pressure is in. My pressure is in kPa, which is kilopascals. And the gas constant that has kPa in the units is 8.314. So that gives me my R, 8.314. And then my temperature is 275 Kelvin. I like to do things one step at a time because if you do things one step at a time, you're certain that you won't make a mistake, okay? So the first thing I'm going to do is multiply all of these guys together. 21.6 times 8.314 times 275. And that gives me, I still multiplying this side, but that's just 150 times the volume, equals 55325.16. So all I did was multiply all those variables on the right hand side together. Now solving for volume is easy because I just have to divide both sides by 150. The volume is equal to 368.8 liters. For an ideal gas law, the volume is always in liters, the temperature is always in Kelvin, the number of moles is always in moles, obviously, and the pressure is determined either by which gas constant you use or what they give you, okay? But it can only be atmospheres, ATM, millimeters of mercury, which is mmHg, or kilopascals, which is kPa.